Long division method to find square root. Now, we can solve an example to find how this long division works. So, we can take a long number with a decimal point as our example, as it will avoid lots of doubt and confusion. Now, let's start. So, this is our number. Here, we need to find the square root of this number. Okay, let's start. Look at the number 656.12. The first step is to mark pairs of digits from the unit's end. But here we have a decimal point. So, this thing changes. What we do is that we mark the pairs separately from the decimal point. From the decimal point towards the ones digit and after the decimal point, that is from the left to the right, we mark pairs. From the decimal point to the left, we can start pairing. Okay, here we have 6 and 5 as one pair and this 6 alone stand as another pair. Now, we can pair the numbers after decimal point. So, we have 1 and 2 as one pair. Now, we look our first pair from the left, which is 6. We have to find the perfect square which is equal to or lower than 6, since 6 is not a perfect square. So, we choose a perfect square lower than 6. The perfect square lower than 6 is 4. But even 1 is also lower than 6. Remember, we always choose the one which is closest. So, 4 is the perfect square which is closer to 6. We know that 2 square is equal to 4. 2 is the square root of 4. So, we write 2 here. Here we move on to our second step. Multiply above and add below. So, first we can focus multiply above. Multiply 2 with 2 and write the product here. So, the multiplied number 2 is written on top. Now, let's come to add below. We add 2 and write the sum here, which is 4. Remember, when we multiply or add, we are doing the calculation with the same digits. In this case, it is 2. If you observed it well, you may notice that I have left some space next to 4. That space is kept for writing some digits. Our next aim is to find this digit. So, we can draw a box here. The next step is to subtract the product from the number above it. The product was 4, so we need to subtract 4 from 6, which is 2. And then we get the next pair down, which is 56. Then we draw a box above which is close to 2 and below under this box. The digits contained in each of these boxes are the same. The next step is very interesting. We use trial and error to find the digits in the boxes. The product of two numbers will give the same number 256 or the number lower than 256. This is how the product should look. What number do you think we can write in the boxes to get 256 or the number below 256 as the product? Remember, the digits in the boxes have to be same. Let's check. We have found the digits in the boxes, so we can go back to the second step. We multiply, add and subtract. After subtracting, we will get 31. But before our next pair, there comes the decimal point. There goes our next step. Place the decimal point to the quotient. Now, you can write down the next pair. That is 12. After this, you can draw the boxes above and below. What number do you think we can write in the boxes to get 3112 or the closest number below 3112 as the product? Remember, these digits in the boxes have to be same. Let's check. So, we have found the digits in the boxes. Now, we can go back to the second step. Multiply, add and subtract. So, we have 76. Now, we can write the next pair down. Here we don't have any leftover pairs. But remember, after this 2, we have many zeros, right? So, we can write these pairs of zeros here. Now, we have 7600. Okay, now let's find the digits in the boxes, which is equal to or lower than 7600. Okay, we have got the number, so we can go back to the second step. Multiply, add and subtract. Commonly, we used to stop this division when we get 2 digits after decimal point. So, we can stop here. This is our result.